Good day, viewers. You are welcome back to Tindanious Maths and Science tutorials. I'm very delighted to see you once again. We are still treating limits of functions, and we've learned about the intuitive idea of limits of functions, and we've also learned about the geometric definition for limits of a function, and we've also learned the rules of limit of functions. And I also promised you that I'm going to give you questions where you are going to apply the rules of limits to questions. So in today's tutorials, let's learn the application of the rules of limits of functions. So the first question reads, find length of the expression 1 plus x squared as x approaches 4 if it exists. Obviously it's what? It exists. Okay, in the course of the tutorials, we'll be giving functions where we realize it doesn't exist. Okay, so we are going to learn that. So for now, the limits we are going to consider truly exist. So I have this. Let's see how we can apply the rules here. Remember, I have 1 plus x squared, right? So I'll spread the limits, okay? So I will partition them such that the limits affects every item or every term inside the parentheses. So I have, so this is the same as lim as x approaches 4, or 4, what do I have here? I have 1. Do you get it that way? Then I have plus, then I have lim as x approaches 4, of what? Of x exponential, that's x what? X squared. Alright? So having done this, I can therefore say that, remember, limits of a constant gives what? Gives that constant. So this is a constant, right? So lim of 1 as x approaches 4 is the same as what? The same as 1. Then plus, this is the same as you put, remember, this is the same as lim as x approaches 4 of x times what? Times lim as x approaches 4 of what? Of x. Do you get it that way? As simple as that. So I'll get 1 plus, wherever I see x, you put 4 there. So what do I have? We have 4 there. Then you have times, wherever you see x, you put 4 there, you have what? Times 4. So this gives 1 then plus 4, 16. So the answer is equal to what? 17. As simple as that. Let's consider the second question. We have this. Remember, you spread the limit, okay? So this one is, we have as x approaches, so this one is as x approaches 2, okay? So let's see how to apply the rules. So this is the same as, I have lim of what? Of x, as x approaches what? 2. Because the limit will affect every term over there. Then I have minus 1, right? So I have lim as x approaches 2 of 1. Then all over, I'll consider the denominator. I have lim as x approaches 2 of x squared. Then I have x here. Then I have plus lim as x approaches 2 of what? Of x. Then I have minus lim as x approaches 2 of what? Of 2. As simple as that. So this is the same as lim of x as x approaches 2. What does it mean? I'll simply, wherever I see x, I put what? 2 there. So this becomes what? This becomes 2, then minus lim of a constant is always what? The constant. Then minus 1. Then all over this, wherever I see x, I put what? 2 there. So I have what? 2 squared. So I have 2 squared. Then I have plus, wherever I see x, I put what? 2 there. So lim x becomes what? 2. Then I have minus, this is a constant, right? So lim of a constant is always what? The constant. I have there. So which is equal to, I have 2 minus 1 gives 1, then all over, I have 4, then plus what? 0. So the answer is what? 1 on 4. Let me see how simple it is. Let's consider this question. So I have length of the expression x plus 5 over x minus 1 as x approaches 3. So what do? So we have length then of x as x approaches what? 3. Then we consider the other one. So I have plus length as x approaches 3 of what? Of 5. And all over, and I have length as x approaches 3 of what? Of x, and I have minus length as x approaches what? 3 of what? 1. As simple as that. So when I put x is equal to 3 into this, I have what? I just simply write 3. Wherever you see x, you put 3 there. Then plus length of a constant is always what? A constant. Then all over length of x as x approaches 3. When you put 3 over here, you get what? 3. Then minus length of a constant is always what? A constant, 1. So I have this plus this. I have 8 over what? Over 2. So the final answer becomes what? 4. As simple as that. To throw more light on this, let me consider the last question. So we have length of 3x minus 4 all over x plus 1. So let's consider the last question. Length of the expression 3x minus 4 over x plus 1 as x approaches 1. So this is the same as what? Length as x approaches 1 of what? 3x. Then minus length as x approaches 1 of 4. Then all over length as x approaches 1 of what? X, then plus length as x approaches 1 of 1. As simple as that. This is the same as length as x approaches 1. We have 3x. It means 3 times x. So I have 3 here. Then I have times length as x approaches 1 of what? Of the x. Then I have minus length as x approaches 1 of 4. Then all over length as x approaches 1 plus length as x approaches 1 of 1. So I have limit of a constant gives what? That constant. So I have 3. Then times, when I put 1 into x, I have what? I have 1. So I have length of x as x approaches 1 is the same as what? 1. Then I have minus length of a constant is always what? A constant, which is my 4. Then all over length of x, wherever you see x, you put 1 there. So I have what? 1. Then plus length of a constant is always what? A constant, which is 1. So I have 3 by 1, I have 3. Then minus 4. All over 1 plus 1 gives what? 2. So this is the same as what? Negative 1 over what? Over 2. As simple as that. Viewers, subscribers, listeners, this is the end of the tutorials. So far as this YouTube channel is concerned, we are going to learn, we are going to explore.